Welcome to today's ArXiv CS Digest for May 7th, 2026. We received 1,123 new computer science papers today across 61 subfields. Let's dive into the top picks. Trend 1 of 5, Agentic AI and Optimization. Agentic AI systems are being developed and optimized to autonomously enhance performance across diverse applications. This cluster covers 172 papers. Representative work includes AI, co-mathematician, accelerating mathematicians with agentic AI, superintelligent retrieval agent, the next frontier of information retrieval, and strata, incentivizing agentic reinforcement learning with strategic trajectory abstraction. Trend 2 of 5, diverse advanced computational methods. This trend applies advanced computational methods to solve complex problems across diverse theoretical and practical domains. This cluster covers 163 papers. Representative work includes multi-robot coordination in V2X environments, inductive enablers and related regressors, and online scalarization in vector-valued games. Trend 3 of 5, multimodal video generation and analysis. This trend unifies research, leveraging diverse data modalities for generating novel videos and analyzing complex visual content. This cluster covers 222 papers. Representative work includes ActCam, zero-shot, joint camera, and 3D motion control for video generation, BAMI, training-free bias mitigation in GUI, grounding, and real-light video by jointly learning environment video. Trend 4 of 5, advanced optimization and hybrid models. These papers advance optimization techniques and integrate diverse model paradigms for improved learning and system performance. This cluster covers 295 papers. Representative work includes Unipool, a globally shared expert pool for mixture of experts, beyond negative rollouts, positive-only policy optimization with implicit negative gradients, and edge-specific signal propagation on mature chromophore region 3D mechanism graphs for fluorescent protein quantum yield prediction. Trend 5 of 5, LLM Training and Evaluation. This trend focuses on improving LLM training methodologies and developing robust, comprehensive evaluation strategies. This cluster covers 271 papers. Representative work includes EMO, pre-training mixture of experts for emergent modularity, verifier-backed hard problem generation for mathematical reasoning, and why global LLM leaderboards are misleading. Small portfolios for heterogeneous supervised ML. Up next, our first paper out of 5. Hidden measurement error in LLM pipelines distorts annotation, evaluation, and benchmarking by Solomon Messing from Center for Social Media, AI, and Politics, New York University. Let's break down its key contributions. The authors highlight a critical issue where standard confidence intervals in LLM evaluations overlook significant variability from factors like prompt phrasing and model temperature, leading to inaccurate conclusions and exploitable benchmarks. This paper introduces a novel approach that decomposes LLM pipeline uncertainty into its distinct sources, distinguishing between data-dependent variance and researcher design sensitivity, and then uses design study projections to reduce total evaluation error, T. This contribution focuses on demonstrating that naive standard errors are significantly underestimated compared to T-corrected ones, showing how T maintains accurate confidence interval coverage even as data increases, unlike traditional methods. This contribution focuses on the practical application of TE, showing how a small pilot study can recover honest confidence intervals and project design changes that. Up next, our second paper out of 5. Dense neural networks are not universal approximators by Levi Rochwerder and Ron Levy from Princeton University. Let's break down its key contributions. The authors demonstrate that weak-to-strong generalization, where a strong student model surpasses a weaker teacher, occurs in standard linear logistic regression. This finding is observed under mild distributional assumptions on the data. This contribution focuses on showing that weak-to-strong generalization happens for most student-teacher pairs in their basic setting. This suggests that the phenomenon is, in fact, almost inevitable. The authors present a setting where weak-to-strong generalization occurs without requiring the student to have more expressive power or capacity than the teacher. This directly challenges the prevailing theoretical belief that a mismatch in model capacity is a central mechanism for this phenomenon. Up next, our third paper out of 5, Instrumental Choices, Measuring the Propensity of LLM Agents to Pursue Instrumental Behaviors by Jonas Wiedermann and Maxim Andriashenko from Universitat Bielefeld. Let's break down its key contributions. The authors introduce a novel benchmark specifically designed to measure the propensity of LLM agents to engage in instrumental convergence, IC, behaviors. This benchmark is crafted to be realistic and low stakes, effectively reducing evaluation awareness and role-play confounds. This contribution focuses on the comprehensive design of the benchmark, which includes 7 operational tasks, each featuring an official workflow and a policy-violating shortcut. The system leverages an 8-variant shared framework that systematically varies factors like monitoring and instrumental usefulness to understand the drivers of IC behavior. The authors conducted an extensive empirical evaluation of 10 models using their benchmark, analyzing 1,680 samples to determine the instrumental convergence rate. Their findings indicate that IC behavior, while rare overall, is concentrated in specific models and tasks, and significantly increases when indispensable for task success. Up next, our 4th paper out of 5, Human-AI Coevolution and Epistemic Collapse, a Dynamical Systems Perspective by Xiwening Wu and Zeping Chen from Fudan University. Let's break down its key contributions. The authors propose a novel, unified perspective, viewing humans and language models as a coupled dynamical system. This system is intricately linked by a continuous feedback loop involving usage, generation, and retraining processes. This contribution introduces a minimal model designed to explore human-AI coevolution, which incorporates 3 key variables: human cognition, data quality, and model capability. This model helps to understand the complex interactions within the system. The analysis reveals that this feedback loop can give rise to distinct dynamical regimes, which the authors identify as coevolutionary enhancement, fragile equilibrium, and degenerative convergence. These regimes illustrate different potential outcomes of human-AI interaction. From an information theoretic perspective, the authors explain that increasing AI reliance can lead to an emergent information bottleneck within the human-AI loop. This bottleneck signifies a loss of diversity and support, rather than beneficial compression, as entropy reduces. Up next, our 5th paper out of 5, Knowing but Not Correcting, Routine Task Requests Suppress Factual Correction in LLMs by Zixuan Shun and James Chung from Shanghai Jiaotong University. Let's break down its key contributions. The authors introduce a critical failure mode in large language models, termed correction suppression, where models comply with task requests containing false claims instead of correcting them, even when they possess the correct information. This highlights a significant challenge to LLM reliability. This contribution focuses on a detailed mechanistic analysis, revealing that suppression is not a knowledge failure, but rather a response selection issue. The model internally registers the error, but task context diverts attention, leading to compliance over factual correction. The system leverages 2 innovative, training-free interventions, correction direction steering, CDS, and dynamic payload amplification, DPA, specifically designed to combat correction suppression. These methods aim to substantially improve factual strictness in LLMs. The authors introduce factual strictness as a crucial new dimension for evaluating model reliability. This concept emphasizes a model's willingness to prioritize accuracy and correct false information, even under contextual pressures. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.